Good morning, students. This is the third part of our chapter 3, that is metals and nonmetals. Today we will cover the topic formation of ionic compounds and their properties. So let's start reaction between metals and nonmetals. When we look at the electronic configurations of metals and nonmetals, we find that their octet is not complete, and hence they form ionic bonds to form various compounds by transfer of electrons. The two oppositely charged ions bind together with the help of strong electrostatic forces of attraction, which is termed as ionic bond or electrovalent bond, and the compounds having such bonds are called ionic or electrovalent compounds. Well, we can give another definition. A chemical bond formed by the complete transfer of electrons from one atom to another is called ionic bond. Such compounds are called ionic compounds. Metals lose their electrons to form positive ions called cations, and nonmetals gain these electrons and acquired a negative charge called an anions. So this means ionic bond is formed between metals and nonmetals. Here in the slide, as you can see, the atomic number and number of electrons in shells of some elements. In case of noble gases, the outermost shell is complete and hence they do not react with other elements. Now, look carefully at the outermost shell of metals and nonmetals. What do you notice? The outermost shell of that is valence shell of metals have lesser electrons, that is 1, 2 or 3 electrons, whereas nonmetals have more than 4 electrons in their outermost shell. It means it will be easier for a metal to lose electron in comparison to a nonmetal. Metal loses electron to gain stability, and this electron is received by nonmetals to complete its octet and form ionic bond. The next slide shows the electron dot structure of sodium, oxygen and magnesium. The number of dots around the symbol of the elements is equal to the number of electrons in valence shell. Sodium has 1, oxygen has 6 and magnesium has 2 electrons in its valence shell. Let us take very common example of sodium chloride, that is NaCl. So first we will discuss sodium and its electronic configuration. Sodium has an atomic number 11 and the electronic configuration is 281. The valence shell has 1 electron. Now sodium acquires positive charge, that is Na cation will be formed when it will lose 1 electron, as we have shown in the slide. Na 2,8,1 is equivalent to Na positive plus 1 electron. Now we will discuss chlorine. It has atomic number 17 and electronic configuration 2,8,7. We can see that to complete its octet there is need of 1 electron. When chlorine gets this 1 electron, it acquires a negative charge to form Cl negative anion. Cl negative is equivalent to 2,8,8. So we know the basic rule that positive and negative attracts each other. Sodium loses its 1 electron which is gained by chlorine to form NaCl, sodium chloride, in which sodium is the positive part and Cl is the negative part. This electron dot diagram which is shown here is very important and is often asked in board exams. I have already told you about the electron dot structure of various elements. Sodium with 1 dot shows its valence electrons, which is 1, and chlorine with these crosses shows 7 electron and 7 valence electrons. 1 electron from sodium is transferred to chlorine, and so sodium acquires positive charge and chlorine acquires negative charge, and these two oppositely charged ions form NaCl or sodium chloride. To make it more clear, let's take one more example. This time we will take example of calcium chloride, which has formula CaCl2. Atomic number of calcium is 20 and its electronic configuration is 2, 8, 8, 2. The electron dot structures, two dots with symbol of calcium Ca are shown. To complete the octet, calcium has to lose 2 electrons. So where will these 2 electrons go? In the last example, we have seen that one atom of chlorine needs 1 electron to complete its octet. So we will need 2 atoms of chlorine to get 2 electrons from calcium. The electron dot diagram is very clear. 1 electron from it is transferring to one atom of chlorine and the other electron of calcium is transferring to the other chlorine atom. And finally, we get calcium chloride, that is CaCl2. Next, we will discuss the properties of ionic compound. First is physical nature. Ionic compounds are crystalline solid because of strong forces of attraction between the positive and negative ions. These are generally brittle and break into pieces when pressure is applied. Next property is melting and boiling point of ionic compounds. These compounds have high melting and boiling points as large amount of energy is required to break strong force of attraction. Third property is solubility. These compounds are soluble in water and insoluble in organic solvents like kerosene, benzene, ether, petrol, etc. Last and the most important property is conduction of electricity. For example, sodium chloride in solid state does not conduct electricity, but in aqueous solution it conducts electricity. So we can say that ionic compounds are good conductor of electricity, but they conduct electricity either in molten state or in their aqueous solution. A solution of an ionic compound in water contains ion which move to the oppositely charged electrode when electricity is passed through it. So students, today we discuss about ionic compounds. It's a small topic but very important, and revise it regularly. Thank you and have a nice day.